Preface. This is a book about transformation, the turning of one thing into another, followed across a wider range than any single discipline usually allows. It moves from the nucleus of the atom to the interior of stars, from the biology of a cell struck by radiation to the politics of fear that radiation inspires, from spent reactor fuel to the batteries that might be built out of it. It moves from the nucleus of the atom to the interior of stars, from the biology of a cell struck by radiation to the politics of fear that radiation inspires, from spent reactor fuel to the batteries that might be built out of it, and finally to the far edges of speculation, where old dreams of energy and hidden knowledge still exert their pull. The thread that runs through all of it is the ancient and once forbidden idea that the elements are not fixed, that under the right conditions Mercury really can become gold, and that the universe has been performing such transmutations quietly and at unimaginable scale since long before anyone was here to watch. Because the book travels so far, it holds itself to a simple discipline, and I want to state it plainly at the outset. Not every idea in these pages carries the same weight, and I have tried never to pretend otherwise. 3 registers appear throughout, and they are kept distinct on purpose. The first is verified science, the settled, well-evidenced core that you could find in any university course: how decay works, how a reactor works, what radiation does to DNA. The second is the plausible but unproven frontier, real research and engineering that has not yet arrived, or not yet at scale. Diamond batteries, thorium reactors, superconducting grids, mercury to gold by fusion. The third is openly labeled speculation, ideas outside the scientific mainstream, from pyramids read as machines to wireless power on a planetary scale. These I present because they are genuinely interesting, and because a curious reader deserves to meet them. But I present them as what they are, with the mainstream view stated fairly beside them, never dressed up as established fact. The opening of the book is a 4th kind of writing again, a short work of fiction. Chapter 1 imagines Benjamin Franklin in a storm, and it takes a deliberate liberty with history for the sake of setting a mood. It is labeled as fiction where it ends, and nothing in it should be read as a historical claim. 8. It is there because the questions it dramatizes, can the elements change? Can lightning transform matter? Are the real questions the rest of the book takes up in earnest. On sources, where a claim is load-bearing, a half-life, a date, a figure, a specific result, I have tried to tie it to a real, checkable reference, and the guide to sources at the back gathers those by chapter. I have not invented citations, and where the evidence is thin or contested, I have said so rather than papering over it. Some of the most striking recent claims in these pages: a startup's announcement that fusion could make gold, viral reports of structures beneath Giza, are exactly the kind that deserve caution, and I have flagged them as announcements and proposals rather than proven results. The book is written for the general reader who is willing to think, someone with no special training in physics who is nonetheless unwilling to be talked down to. The science is explained in plain language, built up from images and analogies rather than equations. You do not need to have read the previous chapter to follow the next, though the chapters are arranged so that the ideas accumulate. A last word on the spirit of the thing. It is easy, in a culture that has learned to fear the word nuclear, to treat this whole territory as something to be managed and contained. I have tried instead to treat it as something to be understood, because understanding is the only thing that reliably turns fear into judgment. Whether the subject is a spent fuel rod, a fruit fly, a superconducting cable, or a 4,000-year-old pile of limestone, the invitation of this book is the same. Look closely, keep the categories honest, and let the strangeness of the real world be enough. 9. Introduction. Every chapter of this book is a variation on a single sentence. The elements are not fixed. It is one of the oldest hopes the human mind has entertained and one of the last to be vindicated. The idea that matter is not a closed inventory of unchangeable substances, but a slow, restless process, and that under the right conditions, one thing can, in fact, become another. For most of recorded history, that hope had a name, alchemy, and a reputation for ruin. Men spent fortunes and lifetimes trying to coax gold out of baser metal in furnaces that could never reach the one place the change was possible, the nucleus of the atom, sealed away beneath the chemistry they knew how to touch. Then, in the space of a single century, the sealed door came open. Physicists learned to split heavy nuclei and to fuse light ones, and the transformation the alchemists could not force turned out to be not only real but commonplace, the quiet business of every star, and, once we understood it, a thing we could do ourselves. This book is a survey of that transformation in all its forms, followed from the settled core of physics out to the ragged edge of what is still only imagined. It is written on the conviction that the whole territory is far more interesting understood than feared, and it keeps a promise to the reader throughout, that the three very different kinds of thing it discusses will never be allowed to blur together. There is the verified science, the settled and well-evidenced core you could meet in any university course. There is the plausible frontier, real research and engineering that has not yet arrived at scale. And there is open speculation, ideas outside the scientific mainstream that are offered because they are interesting, and always with the ordinary explanation set fairly beside them. The ground grows less certain as the book goes on, and I have tried to say so at every step, so that the reader always knows whether we are standing on rock, on scaffolding, or on open air. A half-life is rock. A thorium reactor delivering power to a city is scaffolding real but not yet built. A pyramid rewired into a power 10. Station is open air. The reader is owed the difference, and this book tries never to charge the same admission for all three. What follows is arranged as a journey outward in 5 parts and a conclusion. Any chapter can be read on its own, but the ideas are meant to accumulate, and the order is deliberate. We begin with what transformation means, pass through what radiation does to living things, and to the politics that surround them. Look hard at the waste that nuclear power leaves behind and the ways it might be reused. Survey the generative systems that could plausibly power the coming century and end among the frankly speculative. A brief word on each stage will show the shape of the whole. Part 1 asks the question that frames everything after it. What does it actually mean for one thing to become another? It sets out the physics of nuclear change in plain language, how atoms decay, how they split and fuse, and why this, and not the furnace, is the mechanism the alchemists lacked. The turning point has a date and a place. In 1919, in a laboratory in Manchester, Ernest Rutherford bombarded nitrogen with the particles thrown off by radioactive matter and turned it, atom by atom, into oxygen. The first time a human being had deliberately changed one element into another. From that single result, the book widens its lens to the largest possible frame, an electrical plasma-filled universe in which transformation is not the exception, but the ordinary condition of matter. The carbon in our bodies and the iron in our blood were assembled inside stars and scattered by their deaths. We are, quite literally, the ash of old transmutations, and the same fire still burns from the core of the sun to the thin, charged gas between the stars. Underneath all of it is a simple accounting the alchemists never had. Nuclei give up energy when they move toward the most tightly bound arrangements in the middle of the periodic table, which is why splitting the heaviest atoms and fusing the lightest both release power, and why iron sits, indifferent, at the bottom of the valley they are all sliding into. Part 2 turns from the atom to the cell. Its subject is radiation and life. what high-energy particles actually do when they pass through living tissue, how they can damage and now and then rewrite the genetic code. 11. And why the same force that causes a mutation can also be measured, shielded against, and put to work in medicine and biology. The science here has faces. Herman Muller, in a banana-scented laboratory in Texas in 1926, firing X-rays at fruit flies and watching heredity itself buckle under the beam. But the story does not end at the bench, because radiation is the one branch of physics that has become genuinely frightening to the public, and the book takes that fear seriously rather than scolding it. The final chapter of the part traces how the word nuclear came to carry so much dread, and makes the argument the whole book leans on, that understanding, not management, is what changes fear into judgment. Part of that understanding is admitting what is still unsettled, most of all the long-running dispute over very small doses, where the cautious assumption that every particle carries some risk collides with evidence that the body shrugs off low exposures it has lived with since life began. Part 3 takes up the problem almost everyone raises first, the waste. Spent reactor fuel is usually described as a curse to be buried and forgotten, and the book begins where the fear does, on the walkway above a spent fuel pool, 40 feet of clear water lit from within by an eerie blue Cherenkov glow. But it treats that waste as an unfinished resource rather than a tomb. It explains how the long-lived, most troublesome components can be chemically separated and then transmuted in the great reprocessing halls on the French coast and in the reactor designs meant to burn what those halls recover, so that transmutation reappears not as a fantasy, but as a working tool for shortening the very hazard people fear, and it follows the same byproducts outward in a more hopeful direction. The lump of plutonium keeping a spacecraft alive as it crosses out of the sun's domain, and the long-lived nuclear batteries closer to home that run on nothing but patient decay. The stakes are set by time itself. Some of this material stays dangerous for tens of thousands of years, longer than any language or institution has ever endured. And that yawning gap between the hazard and anything we can promise to maintain is the strongest argument for turning the waste into something shorter-lived rather than simply burying it and hoping. 12. Part 4 is the book's tour of the plausible frontier, the engineering that is real and already underway but has not yet reached us at scale. Here are diamond batteries that lock waste carbon into a crystal and draw a faint current from it for millennia. Microreactors small enough to truck to a site, built in the spirit of the old naval dictum that a real reactor is simple, small, and cheap. Thorium and molten salt designs descended from a cherry-red liquid reactor that actually ran at Oak Ridge in the 1960s, and the distributed, always-on power that the coming age of data centers will demand. The part then follows electricity itself into two of its strangest futures. Superconductors, which since Kamerlingh Onnes chilled a thread of mercury in 1911 have carried current with no loss at all, and which could remake the grid if they can be made to work warm, and wireless power, the dream that raised Tesla's great tower on Long Island, and that returns today in the quiet form of a phone charging itself on a cafe table. None of it is science fiction, and none of it is a finished product. Each is presented for exactly what it is, promise and open problem side by side. Part 5 is where the book allows itself to wander, openly and with its labels showing. It considers the Great Pyramid, 2 1/3 million blocks, stacked with a precision that still unsettles the eye. Read not as a tomb, but as a machine, and asks what such a reading would have to explain and where it fails. It weighs the persistent modern reports of chambers and systems beneath the Giza Plateau against what the actual instruments, muon detectors reading the rain of cosmic rays through solid rock, have and have not found. And it ends on the oldest dream of all, Mercury into gold, which turns out to be the strangest vindication in the book. Modern physics really can perform that transmutation by fusion and by neutron bombardment at a cost so preposterous that it turns the alchemist's fantasy into a footnote. In every case, the mainstream account is set fairly beside the speculation, and the reader is trusted to weigh them. The conclusion draws the threads together and asks what actually connects a lightning storm, a fruit fly, a spent fuel rod, and a 4,000-year-old pyramid of limestone. The answer is the single fact the whole book was written to take seriously, that matter flows, that every stable form is a 13, temporary arrangement within an older and continuous change, and that the ancient question, can one element be turned into another, has finally been answered yes, with a precision and a list of costs that make the answer stranger and far more useful than the fantasy ever was. A book of this kind is a snapshot of a moving target. Between the time these chapters were written and the time they are read, some of the frontier technologies will have advanced, some will have stalled, and at least one of the bolder announcements will likely have been quietly revised. That is not a flaw in the subject. It is the nature of working at the edge. What I hope will outlast the particulars is a habit of mind rather than any single prediction, to hold the categories apart and to ask of every dazzling claim not merely whether it is true, but which kind of claim it is, settled science, honest frontier, or speculation wearing the costume of fact. The elements will go on transforming with or without our attention, in stars and reactors and the slow decay of a stone. The one transformation that is ours to make is the one in how we choose to see them. 14. Floor was laid in a black and white pattern of squares that made the center of the hall resemble a game board waiting for pieces. At the far end stood the master's chair, elevated by a few steps and backed by carved pillars, while lesser seats flanked the sides in strict, orderly rows. An altar occupied the middle of the room, plain in form but carefully placed, with a square and compasses resting upon an open volume whose pages caught and held the light. Franklin had sat in many such rooms over the years, in Philadelphia, London, and Paris, and though the decorations differed, the style of the chairs, the pattern of the molding, the particular emblems hung upon the walls, the effect was always the same. The lodge was designed to suggest both secrecy and order, a geometry of space meant to remind the men within it that they were, for a time, participants in something older and larger than their own affairs. Conversations here were rarely idle. Ideas were weighed and exchanged with the same care that bankers reserved for coin. Tonight, the air was thick with perfume and candle smoke and the murmurs of brethren lingering after the formal work had closed. The ritual had been simple enough: a lecture on virtue, a few petitions, the reading of correspondence from other lodges across the sea. Now the aprons had been loosened, the gloves tucked away, and small clusters of men gathered in the angles of the room and near the doors, their voices dropping as topics grew more speculative. Franklin stood near one of the tall windows, his back to the pane, a glass of wine held lightly in his hand. He listened with half an ear to a brother beside him recounting a minor political intrigue in the assembly, but his attention kept slipping to a knot of men some distance away near the eastern wall. Their heads were bent close together, their gestures more animated than the slow, measured movements of polite conversation. From time to time a word drifted across the intervening space: mercury, flux, essence, catching his interest like sparks landing in dry tinder. He let his companion finish a sentence, made an appropriate reply, and then allowed himself to drift, as if idly, along the perimeter of the room. In 1910 was easy enough to do. Men moved, chairs were shifted, a servant passed with a tray. Franklin stepped aside to let the man go by, and found himself quite naturally on the edge of the conversation that had drawn his curiosity. Not vulgar alchemy, one of the men was saying, a tall fellow with a narrow face and a French accent softened by years abroad, but a matter of arrangement. If the principles of attraction and repulsion are as our brother Franklin has written, he inclined his head in Franklin's general direction without quite looking at him. Then it follows that the forms of matter themselves might be altered if one could but apply the proper force in the proper manner. Transmutation, then, another replied with a touch of skepticism. You would have us believe that mercury may become gold if only it is jostled firmly enough by nature? Not by heat in a furnace like a medieval charlatan, the Frenchman said, by fire of another kind. Consider lightning, monsieur. Consider that it is not merely a sign of the heavens' displeasure, but a discharge of an immense quantity of what our English friends call electricity. If such a quantity can be directed, he made a gesture as if drawing a line from above to below. Might it not rearrange the very corpuscles of a precious metal, drive them into a new order, perhaps even toward gold itself? A third brother chuckled, but without malice. You propose to mint the king's coin with thunderclouds? Not I, the Frenchman said. I am no Prometheus. I propose only a question. If a small spark can attract, can repel, can leap from point to point and animate dead frogs, what then of a great spark? What then of a bolt that travels from cloud to steeple? What might it do to a metal if it were confined, if the metal were presented to it in some proper vessel, joined to the earth below and the sky above? Franklin felt his pulse quicken a little. The talk of vulgar alchemy did not much interest him. He had no patience for men who spent fortunes on furnaces in pursuit of philosophers' stones and elixirs. But the notion of lightning as a tool, as a force that might do more than strike and vanish. 20. That touched a part of his mind already worn into patterns by years of electrical experiments. He had drawn sparks from glass tubes, seen charged points glow, felt the sting of Leyden jars. He had reasoned, on paper and in letters, that lightning was of the same nature. Now listening, he imagined something more specific. He saw in his mind's eye not a vague, proper vessel, but a jar, clear and strong, with a metal key suspended in a bath of quicksilver. He imagined that key joined by a string to a point raised high in a storm, the other end of the system rooted firmly in the earth. Lightning traveling along that path would not only leap from cloud to ground, it would be forced to pass through the small world of the jar, through the constrained company of key and mercury, before it escaped into the soil. What might such a passage do? Would the metals simply receive the blow and return to their former state? Or would some subtle change, too small for the eye but not for the balance, take place within? He realized that the men near him had grown more speculative still, speaking of ancient legends, of Hermes Trismegistus and metallic seeds planted in the earth. Franklin let their words wash past him. He had no appetite for mystic genealogies of gold, yet some of the phrases lodged in his hearing. Gold as perfected precious metal, gold as the end toward which lesser, baser metals strove. If precious metals could be perfected, then perhaps they could also be persuaded or coaxed from their baser cousins. And if they could be persuaded, lightning might be the most eloquent orator nature provided. A brother addressed him directly, jolting him from his reverie. "Dr. Franklin," the man said, smiling, "you have been quiet. What say you? Could your beloved electricity turn a pewter plate into a guinea?" Franklin returned the smile, though his thoughts were already in another room, among his jars and wires. "I say," he replied, "that nature will do as she pleases, whether we coax her with Latin or with bottles. But if she is inclined to answer such a question, I should like to be present when she speaks." 21. There was a ripple of laughter, a few good-natured remarks about American boldness, and the conversation turned to other matters. Franklin allowed it to drift away from him. His mind had already left the lodge, stepped out into the damp Philadelphia streets, and gone ahead to his workroom. The tiled floor beneath his feet was carved all